Woo! We're back. Story time with Rhett. I'm your co-host, Christopher De Leon, and I'm super excited. Back by popular demand, we have Failure Files 2.0. I have to admit, Rhett, I know. I've been reluctant to jump right back in because of all the successes we had with Fail Fires 1.0, but we're here.
It was nearly 2 years ago.
But we're here. The floor is yours.
So today, Chris, we're going to something that all of our audience is definitely old enough to remember, but it was in a different industry, a sister industry, but close. I just give you the stakes. 210 million gallons of crude oil into the Gulf of Mexico, an oil slick that covered 60,000 square miles of ocean. It's larger than most U.S. states. The state of Georgia is actually 59,000 square miles. And in a well located 48 miles off the coast of Louisiana. So what we're talking about today is the BP Macondo oil spill from April of 2010. Most of us old enough to remember it, but I question whether or not we've understood the lessons and their very direct application to pipeline integrity. It's going to be a fun episode. Stick around. Welcome back to the Failure Files.
Giant fireball there.
Police yell for motorists to get moving as a huge wall of smoke and flames.
Homes destroyed after a huge explosion last night. It was apparently caused by a broken gas.
Chris, do you remember where you were on April 20th, 2010? That's a question for the audience too, but I'll start with you.
Yeah, I was at 5444 Westheimer working as an integrity engineer for Energy Transfer.
So most people probably don't associate,
Actually, depending on the time of this, I might have been thinking about lunch. Wasn't this around like 10 o'clock-ish? Around there? Is mid-morning?
Maybe by the time you heard about it, definitely probably so.
I think so.
The reason I asked that question to Chris, the significance of that date, I'm starting to think there are a lot of dates in April. Waco, Oklahoma City bombing, this. I'm like, what is going on in April?
Right after spring break.
April 20th, 2010 is when the Deepwater Horizon experienced a blowout.
Yeah.
For those of you who are listening to this episode, Deepwater Horizon is the name you probably remember it. BP oil spill is the other name you probably remember it as. I actually knew it as Macondo because I knew the well name, right? So you're going to hear me throughout this episode talk a lot about Macondo. Macondo was actually the name of the well that they were drilling, and fewer people actually know it as that name. But we're talking about the Deepwater Horizon incident. I remember it distinctly because I was working at Stress Engineering at the time, and I was still pretty heavily involved in the offshore industry. Stress got drug in, like every single company in Houston got drug into that, right? And then you remember it affecting, I don't know, at that point in time, we had vacations planned to Gulf Shores. There were questions about whether or not you could go to Gulf Shores. The oil started coming up on the shore. And that's what most of us remember from this event. Miles, the images, the duration that it went on, right? So this story begins on August 20th, whenever the rig is on fire. It burns for 2 days before it eventually sinks to the seafloor.
Yeah.
They had, people were jumping off of the rig. We didn't get a lot of those images, but I mean, people don't appreciate this rig's like 125 feet above the sea. The seafloor, not the seafloor, I'm sorry, mean sea level, right? So it's jumping off of a big high. I mean, this is a lot.
If you want to reflect, like we were on that day in the building I was on the 9th floor. I distinctly remember how high that was. And so you're going to tell me I'm going to jump out of there into the ocean?
Yep. While the rig is on fire. I mean, that was a level.
Yeah.
But fortunately, and I say fortunately, of the 126 people on board, 115 were rescued, which does, I think, speak to the safety protocols that they had in place. But we did lose 11. Again, the vessel eventually sank. And most of us remember the aftermath. Because it didn't end. The vessel sank, but then this saga continued for 87 more days while I remember they had ROV footage. If you remember that time, you could actually log on to the internet and you could see the ROV footage. You could see it spewing. Yep. You were getting all these experts. Every news channel was filled with experts talking about stories about how long the recovery would be. Would we ever be able to do this? What was going to happen? It was an amazing time, I will say.
Maybe amazing is not the right word.
When I say amazing, I mean amazing.
I don't think
like
amazing is the right word.
A thunderstorm.
It still frustrates me quite
amazing.
a bit. Like I'm getting a little bit frustrated again.
And look, we're like many of the aspects.
I mean, and one of my
still remain unsolved to this day.
Like one of my favorite parts about failure files is story time with Rhett. And I can already project how I'm going to feel. Like, I know that as you start getting some of the consequences of what this happened, like,
So it's great. I'm glad I got you worked up.
yeah, I'm probably going to be a little bit fussy.
But I hope that you see yourself in the decision. So let's get to what happened here. So, and I'm going to break this down. If we have anybody that's really, really deep into wells, maybe if we have some petroleum engineers out there, you're probably going to take exception to some
or
of what
people
I
like
say.
you that ran away from upstream to come into midstream.
Yes, but I didn't work in the well side. I actually worked about everything above the well, right? But it's still, I understood the technology, I understood what was going on. So I'm going to try and explain it at a level, Chris, so that you understand what's happening in the decision, because it's the decisions that matter in this story, right? So when you drill a well, obviously it's like drilling a hole in your ground. It's just a straight hole, right? And one of the things that you have to do is you have to case that hole to keep it from falling, to keep the material from falling on itself, to stabilize the hole so you can go down like 30,000 feet. You actually have to stabilize the hole, right? And so that's number one. Then inside of that, we actually put another production casing. So you imagine you have an outer casing that keeps, the well intact, if you will. Then you have an inner casing that is actually where your production fluids come up at the end of the day, right?
Yeah.
One of the things that you have to do, right? So, and again, I'm simplifying the process greatly, is eventually at the bottom, you need the production fluids to come through, and they actually only need to come through that production casing in the middle. So imagine two tubes, right?
I'm hoping not through the space between the annulus between the earth and the outer casing.
That's one very important annulus. And the second important annulus is between that, what's called the well casing and the production casing.
Okay.
The annulus between the well casing and the production casing isn't the critical part here. It's actually between that one on the outer that you're talking about. So
the earth, and we're going to call the overall well.
Yes. In order, we don't want it to come up that way. So what we actually do is they pump cement down through the bottom. And so we pump cement all the way through the bottom of the production. It comes up, and then it goes and it seals that annulus around the edge.
Okay. So again, visual guys, we want to see what you're saying. Once you have the well, you've tapped into the formation that you're trying to get oil and gas out of. You then pump cement into that same formation, and it's going to rise and kind of create a sealing element from the inside to keep oil and gas from going anywhere through the straw.
Other than the production.
The straw that we've now put in the earth.
Yes. Right. So
this is so good. So hold on. So it's like you take a Coke bottle, yeah, and you drill a little hole on the screw on the plastic cap. You put a straw in it after you've shaken up the Coke bottle, and you're hoping that all the Coke comes up through the straw and not through the hole in the gas in the cap.
Yeah,
because it's in pressure, right? You're shaking up the Coke,
right?
and
so
it's going to go everywhere. So you're trying to contain it.
You bring up another thing which I need to discuss, which is how wells in general work. Because when we drill them, we actually drill into these high pressure formations, and the pressure in the formation is high enough to push the fluid all the way back up through the pipe.
That's what I'm thinking.
We counteract that with drilling mud, right? So drilling mud is something that is heavier than water.
Okay.
And what we do is we fill the pipe with so when we're drilling, that whole production casing or that center casing is filled with drilling mud, which is heavy enough to put a pressure at the bottom that prevents the fluid from coming back up, right? But at the end of the day, we can't produce with drilling mud in the pipe. So we have to seal it up, and then we eventually will remove that drilling mud. And when we remove that drilling mud, we can get a controlled environment where the pressure in the formation is high enough in order to push the fluids back up there, which is what we want, right? But it's really critical, because when you make the decision to remove that drilling mud from the pipe, you've now removed the protection from the bottom.
Yes.
Right. So before you do that, you need to make sure that the well's integrity is all good. There are no gaps for the production fluid.
There's no pump in the formation, right? This is pressure within the formation that's driving the fluids up.
So as you can imagine here, what they do is when they push the mud through the bottom, it has to come back up around the annulus, and you need it to come up evenly. So a couple of things are really important here. That casing has to be centralized. If it's not centralized, you can get an effect known as channeling, where the mud wants to go up the wide side sooner than it wants to go up the narrow side. And you can get this belief like, hey, we pumped in all the mud we should have pumped. But in reality, you've got a channel for the gas to go up through one side. There are numerous other ways that this can go wrong. I'm not going to get into all of those. Suffice it to say that at the end of the day, what we need is some type of a test to make sure that the well is okay before you remove the drilling mud. Before you remove that last barrier and you say, hey, I'm going to take off all the pressure, I need to make sure this is okay. There's a few ways that they can do this.
Yeah.
Right. This is where the decisions start to happen.
I feel like I'm to the point of where we've just laid the pipe and we're about to do the post-construction hydro test.
So what ultimately happened is the cementing job I just described to you failed. It failed. And what that permitted production fluids to come back up through places we didn't expect it to, all the way up to the BOP eventually when it blew out, because the cementing job wasn't good enough.
And this is after testing or before testing? Like what you just said?
Oh, let's get into that. So they complete the well. Like everything here, Chris, this story is over budget and behind schedule.
No.
Yep.
Hold on. I love story time with Rhett. I don't know if we've painted the picture good enough for our audience. I mean, isn't this like, aren't they also working like a couple miles away?
What do you mean?
Because this is a floating vessel.
Yes.
Right? And isn't it like, I don't know, 1 or 2 miles before they get to the surface, and then they then have to drill like so many feet under the ground? What I'm getting to is like, this isn't like I'm west of San Antonio where I can put my hands on deck. Right. Like this is a floating vessel that is probably 2 miles or so above.
You're 5,000 feet of water. So you're a mile above the seafloor.
The seafloor.
And then you're 13,000 feet below the seafloor. That was the depth of the well at the time.
So there's a lot of calculation and engineering happening here.
There is. Right. There's a lot.
Like you can't just put your eyes on this and say, hey, how's this going? This is all data acquisition systems and calculations and how much product have we used. There's a lot of uncertainty that is being dealt with.
It gets deep. So let me.
What I want to do is I'm trying to understand the big picture here, right? Which is it's like I've got a mile between of depth of water.
Then you've got 13,000 feet below that.
And then I've got 13,000 feet before that.
And at the very bottom of that, you've got a formation that you've tapped into that is high pressure that wants to push fluid back up all those pipes. Right. And so before your protection against that is you've got this heavyweight drilling mud. So the pressure from the vessel top down keeps that from happening, like putting your
fingers on a plug.
Right.
Yeah, your fingers on the water hose.
Because your weight of all that drilling mud, 18,000 feet of drilling mud exceeds the pressure at the bottom.
Yeah.
So the drilling mud would want to go into the formation, but not come back up. It's perfectly balanced. And that whole drilling mud thing is complex.
Now we've kind of painted the picture of.
But you pull that drilling mud out, it's like pulling your finger off the thing. You need to make sure your other safety mechanisms are in place.
I think
there's 2 ways they do this, right? So I told you can get this concept of channeling when you push in the mud.
Through the outer annulus. If you're not careful.
Well, so when they finished drilling the well, the first thing they did is they declared the well was a success.
How do they do that?
Because they were done. So the question came up, we can do a cement bond log test. The cement bond log is one way that we can actually test the adequacy of the cement. Problem is, it takes 18 hours to complete and costs $128,000.
Oh, $128,000.
Plus the time for the vessels to be on.
In 2010.
So you're behind schedule, over budget. We don't need the cement bond log test. That's an extra test.
Just pause. What is the easiest way to describe a cement bond log test?
It would actually, I'm going to say it's a method of inspecting the adequacy of the cement. It's similar almost to like what we would do with inline inspection to some extent, right? You go down there and you do a test to measure that the cement job is adequate.
And that's to mitigate channeling through the outermost annulus between the earth and the well.
Correct.
That sounds pretty important to me, Rhett.
They decided they didn't need it because they had another test.
Are they allowed to do that?
They are allowed to
Is
do
that regulatory? So
No, there's not a regulatory requirement on that.
that is just best practice.
The second
So if
thing,
you don't do that, what do you do then?
there's a well integrity test, right? So what the well integrity test implies is it tests the integrity of the well, right?
Yeah.
So I'm going to tell you what they do. What they do in here is they insert a production tubing through the center of the casing, right? Because I told you it's the mud that holds
I
back
get
the
it.
pressure,
Mhm.
right? And in this production tubing, they don't have the mud. So it's like a way to kind of test it. And what they do is they tap all the way into the bottom. They let it pressure up, and then they close the valve at the top of the production vessel.
Yep.
Right. And then what they do is they bleed off the pressure. And in theory, if they bled off the pressure and there's nothing leaking through the formation, this tubing that they've installed shouldn't get pressurized. Right. Again, I mean, somebody in this audience is going to get like floored because I'm oversimplifying it.
We get it.
They tap in something that's into the pressure part of the formation.
Should have a consequence.
They bleed off the pressure, and they're like, if it's sealed, it shouldn't see pressure again.
And that passes.
What do you think happens?
That passes.
Oh no, they see pressure. So they see pressure in the tubing where they shouldn't have seen pressure. It's a blatant failure.
So now you go back and you do the cement test.
No, so they decided to repeat the test because they're like, something's got to be wrong. So this is where the challenge comes in. They repeat the test and it fails again. Nobody on board. So there's a team on board here, and I want to explain there are 5 people that are involved in this decision-making process. 2 of them work for BP, 3 of them work for Transocean. None of them had ever seen a well integrity test fail. Not once in their combined careers had they ever seen one. In fact, the well integrity test, you would think it's to measure well integrity. That's what you would think it's like a stage gate.
Yes.
They didn't view the test as that because the test was so routine, because it had always passed. They didn't view it. I'm describing it to you as a measure of integrity. They didn't view it that way. They viewed it as just something you check the box to move on before. Like, this test always passes. Why are we doing this test?
But that's a red flag. I mean, that's an obvious red flag.
To you and me? To somebody who's done this multiple times, again and again throughout their careers, they just see this as, this is just check the box. This test doesn't fail. You must have done something wrong.
So did it again.
You must be doing something wrong. So what they began to do is they began to invent theories for why this happened. And one of them was called it was pretty funny. It was called a bladder effect, which makes absolutely no sense. They invented something. They said, oh, that's the bladder effect that's causing this to happen. So they tried to come up with a secondary test, and they ran that test, and then that test gave them the results they wanted. And they were like, oh, it's good. But there were problems with that test, and we think there was a blocked line. Again, I'm leaving stuff out. Problem is, they never endeavored to explain why they had the 2 failures. And when they did, they invented a scenario that technically made no sense, but gave them the justification they need.
It's beginning to sound like a little bit of like confirmation bias, right? It's like, we don't have the intended result that we want. So let me see if I can confirm what I'm hoping is true. That's what it almost begins to sound like here, but
so it's confirmation bias is one way to think about it, but you actually define confirmation bias in a little bit of a different way than most people do, or most people think about it. Are you doing the test to measure the well's integrity?
Nope. The second test that they did it to
confirm the well's integrity.
Okay. Yeah, I was thinking about, again, my statement was more around, it's like they had a result they didn't want, so they tried to rationalize why that happened by doing some secondary activity that confirms that their idea may be true.
Nope. So in this sense, confirmation bias is a psychological phenomenon that refers to the preference people have for information that confirms rather than disconfirms their beliefs. Right? So you have a preference for information that confirms what you want to see rather than disconfirms. And the challenge here...
An example that was then, The integrity test didn't fail because the well is bad. It failed because you don't know what you're doing.
Yes, or it failed. No, it's the test you got failed, right, because of this effect
Yeah.
that we concocted in our mind, right?
Yeah.
And so what happens is, again, I want to take you back. The well was confirmed successful before the test was ever done.
Yeah.
The test actually happened after. The well is safe. They're operating under the mode that the well is safe.
Yeah.
This test is just to check the box. Wait, you're going to stop this whole operation now? We've never even had this happen. I've been doing this for 30 years, bro. This
Never
test
seen
doesn't
this.
fail. You must have done so. Oh, this is the effect you have.
This is easy. We're only a mile above. It's only 5,000 feet of water depth.
And so, exactly, making this real to you, think about it this way. A lot of times when we're dealing with data, whether it's ILI or pipeline or another one, this is where I'm going to make it, you have multiple explanations for why something might have happened. At least one of those explanations is usually benign.
Yeah.
You can tend to want to normalize that anomaly or the other anomalous explanations, which are problematic, right? It's like one explanation for why the test failed is the well isn't sealed. The consequences of the well not being sealed are dramatic and huge.
Yeah.
The other alternative is, it's this bladder effect.
Yeah.
But that bladder effect helps me. It confirms what I want to be. So I tend to want to gravitate towards that explanation.
So again, obviously I know very little about wells, and but I almost want to create a parallel in our world. And one of the questions that it makes me wonder is like, and don't answer this yet. I wonder how significant the integrity test failing actually was. So for example, right, it's like in our normal day-to-day, we deal with a lot of problems. But I think you and I are generally aware of which problems are significant and which ones are ones that can be put on hold for a minute or are of lower consequence to us. And so me being ignorant to this whole process that is happening, I really wonder, because I've seen myself in this situation now, especially on ILI projects.
Oh, yeah, exactly.
Right?
That's where you need to go.
And this is what I'm getting to. It's like, and I'll try to create one ad hoc. How many times have I been on a crack inspection truly, and I have speed excursions, but it's an inferred calculation of the tool speed because I don't know what it's actually doing because I haven't gotten the data yet.
Yep.
But I know if I operate outside the boundaries of the tool's essential variables, I might not get good data, which means I don't get good crack data. But a lot of times we'll overlook speed excursion because we think we can deal with it later. I'm curious, when this happens, are they thinking I can deal with this later, or are they thinking, oh my God, this is significant? We're already behind schedule. We're already over budget.
These are the real drivers. Right? It's, dude, you're doing the test to confirm the well. It's supposed to show that it's good. Why is it showing that it's bad?
We know the well's good because we used the right amount of mud. We used the right amount of cement.
Right.
We didn't have any problems when we were drilling.
Yep.
None of the other KPIs are telling us that there's a problem.
So I'll give you, where this brought it up for me, and we're getting ahead, but it's okay. I want the audience to know we're going to go after the break. I really thought of what happened with Bellingham. Remember the guy's like, dude, I've dug these tuboscope features before.
Yeah, that's not going to be.
But the benign explanation is there's nothing here. This is a tool artifact. The alternative is we have something significant in the pipeline. If that example is not real for our audience in terms of how many times are you looking at situations where you have something that might legitimately be a concern?
I mean, I'll create the suspense. How many times as an analyst, as an ILI analyst, have you seen something that you either over rely on your experience or you say this has never been a problem?
I got one more thing I want to bring out of this failure before the break. And it's a concept. This one struck me. It's a concept of groupthink. So the first one that we're going to come back on after the break and talk about is confirmation bias and normalization. The second one is groupthink. So I told you there were 5 people involved in the decision. 2 BP company men, a trainee, and 2 long-time drillers. The long-term drillers are the guys that have the experience here, right? The person responsible for the decision was the BP guy, 100%. That the buck stopped with him. The reality is they viewed it as a consensus decision where all 5 of them needed to be on board. Now, I've never considered this, but I want people to think of the behavioral norms here.
I get it.
We are not comfortable with a small group of people having one person dissent. We actually expect small group decisions to be unanimous. So the BP guy was uncomfortable with what was going on. He was uncomfortable with the bladder effect situation, but he had two experienced guys who created a peer pressure scenario where he was the only one out, unwilling to accept the benign explanation, and he caves. Because they can't be like, hey, this decision's 4-1. They all need to get on board with the decision. And we're going to see this play out in another failure we're going to tackle too. And I want you guys to think about that. When y'all are in a decision-making room, how comfortable are you with one person who's like, I won't make this decision? We have this tendency to expect, even you and I sometimes, in our company, Chris, when we lead it, you and I make decisions together, but we usually make sure we're getting the other person on board because the decision needs to be both of us. It needs to be unanimous. But what that creates is a situation called risky shift. Not a term you're familiar with? This is a term where groups are inclined to make more risky decisions than any one of the individuals themselves because of the groupthink mentality, and we all have to get to the same place.
Yep. And you know, Rhett, the first thing that comes to mind is conflict management, right?
Ooh.
And the reason why I say that is I think you and I are very comfortable telling each other what we think.
And disagreeing.
And yeah, well, I was getting to that. And oftentimes we will disagree, right? But it's kind of like the principles, if you've ever read The 5 Dysfunctions of a Team, right? It's kind of the idea of like, there is healthy conflict as long as it's debate and not arguing, right? And I would say that healthy conflict often comes if there is an underlying trust, right? Oftentimes when we disagree, right, I trust that your heart's in the right place and you're trying to achieve the right goal.
9 times out of 10.
9. Well, I know. Well, anybody who knows you knows that. But the intent is I think that ability to disagree and to debate for the right reason ultimately does produce better work. But if decision makers are not willing to disagree and manage conflict for the right reasons, then that's a problem, Rhett. It's not just about being an engineer. It's also about understanding how to deal with the social sides of making decisions.
So when we come back after the break, hopefully you're thinking about this. I want to pick up these discussions on confirmation bias, maybe conflict management, groupthink. But stay tuned. We'll be right back. So as we continue our first episode on failure files, look, we went through the failure. This is the point where I want to flip and I want you to put yourself. I want to make it applicable. Like if you feel like we just did an episode on a topic that's not relevant to you, I think you missed it.
Yeah.
And I need you to get it. Because I see myself in these decisions.
Yep.
I mentioned over budget, over schedule. We always deal with economic and timelines on the decisions that we have to make. Those are real decisions. I think the confirmation bias I want to start with, because I think that's more relevant to us than we realize. So that theme of the well integrity test was viewed as a test to confirm rather than to investigate, which completely flips how you view the results of that test.
Yeah.
I'm not expecting that test to give me negative results. It's only there just to confirm that the well is good. It doesn't tell me whether the well is bad. It confirms that the well is good. Those are different mindsets.
Yeah.
My first question to the audience, we deal with ILI a lot. Do you view ILI as something, as a test to confirm the pipe's integrity, or is it to investigate the pipe's integrity?
And I'll follow that question up. And if you're a gas operator, be careful what you think, because we can now do an MAOP reconfirmation via ECA, which is a suite of appropriate ILI tools. So are you confirming or are you investigating?
Hey, Chris, it's really good because how you enter into that process
matters.
If you enter into the
Well, I've
process
never
of,
had a hard spot failure, Rhett. So why do I need to run a hard spot tool?
I am doing all of these ILIs to confirm the pipe's integrity because it was grandfathered a long time ago and it's been operating for years.
Yeah. This is extra.
Don't
I'm already doing extra. We've never had to do this before. I'm only putting these tools in this pipeline to confirm what I already know.
So
did the budget? Oh, oh my God, this is so good. So did the MLP ECA budget, was it based on a philosophy of confirming that it's good? i.e. 2 digs per tool run? Or was that budget set up for investigation where it's, you know what? Each of these ILI tools, we're going to have to make sure we investigate that the tool performance is valid and that we've learned enough about the pipeline such that we feel comfortable continuing to operate this way.
All right, let me. So there's a bunch of our audience that's like, dude, I don't do anything with MAOP reconfirmation via EC. I just turned out. So let me speak to you. When's the last time you normalized a strange ILI signal?
No.
When is the last time you were in a meeting?
Yeah.
I've literally been told this. Let me tell you something, Rhett. When I run that tool, I'm not here to validate your tool because I'm tired of digging things and finding nothing.
Yeah. It's Bellingham, buddy.
I agree.
That was our first episode of Failure Files 1.0.
When I read this, when I saw the whole thing around confirmation bias, I was like, oh my God. Confirmation bias, I think, is more real in the subject of ILI and ILI response than potentially we realize. Let me give you guys another one.
Yeah.
Bending strain geohazards. I find a major bending strain feature. First response. The feature's been in the ground forever.
Yeah.
Does that mean it's not critical?
Does it mean it hasn't changed?
Is past performance a guarantee of future success now? And again, what always drives these decisions, and the audience I know can appreciate this, if we had infinite budget and no economic constraints, we'd dig everything we find.
Even then we wouldn't, but still continue.
I would hope we would. You don't think we would?
I think
infinite budget and no economic constraints. Why aren't you digging things?
Yeah, because someone will find purpose and say that doesn't make sense. It's human behaviors. But what I would say is I want to bring this back around, guys. I think the intent of what we're saying is it's the takeaway from this is if you're in a position as either a consultant, a service provider, or an operator, and you are associated with the pipeline safety or pipeline integrity process, be careful of the mindset in which you're performing your task, such that you're aware of confirmation bias. It's always been like this, and I'm confirming it. Are you testing for compliance or testing to confirm what you think past performance was? Or the big or underlined in bold, or is it to investigate?
Yep.
Because in integrity, the integrity loop, the intent there is to understand the integrity.
Yes.
Not to necessarily confirm it.
Yep.
And we're creating a little bit of a chasm there intentionally for the purpose of this discussion of saying we need to make sure we're performing an investigation. In this case, when they had their first test failure of the well, it should have turned into an investigation. And some would say, but it did. And that's fine. It's less about Macondo and more about our day-to-day. Right? And I think that's what we're trying to drive home.
And for me, it is very real because we've been in that situation where either we're asked to review a signal, and a lot of times when you're asked to give a second opinion, it's because they don't like the first opinion they got, which usually tells them that they need to do something.
Can I give you a real one?
Yeah, you can give me a real one.
Hey, so we got a set of Sharpie results. 2 of them were very favorable. 1 of them weren't.
Oh, yeah.
I just take the average, right?
No, max.
I mean, guys, come on. How many times has this happened more recently, right?
Do you know how many features I'll have to dig if I do that?
So I'm calling you because you want me to confirm that yes, you can be less conservative. Yeah. You're calling me because you want me to confirm your bias.
And again, those integrity decisions are real, right? Like we see it play out on EMAT. You know, there's no reason to dig type B calls on EMAT. I've dug a bunch of them, and I'm sick of finding blank calls. I'm sick of digging dry holes.
Why do you think there's a B? lower confidence. You're not supposed to dig them. That's the whole
Absolutely.
point of this.
I mean, yeah.
There's a reason why when you get these calls, I mean, it started all the way back when you had TFIs. There were A's and B's, right? It's that point. It's focus on the A's, understand what you're finding in the ditch. And then dependent on that, then you can begin to consider the B's. And anybody that's been doing ILS for at least 20 years understands that.
Yes. You don't dig B's. In fact, you don't run crack tools because you don't want to get results you don't have to deal with. So it's easier if you don't run them at all, because then you don't even have to deal with the B's because you don't have to deal with anything.
Well, I would say, yeah. I mean, the whole idea of the B's is those are the monitored ones, though, Rhett. Like the whole intent is that's why we have immediate scheduled and monitors.
The audience right now is trying to figure out what just happened, and they're like, "What do we?"
So we hope you realize we just tried to do the whole group think process on you with type B's, because that is totally wrong.
Which brings us to the next point I think that is important to me, which is that subject of groupthink, right? So again, there are two major applications that I really hope our audience took. The first one I want you to think about is the confirmation bias. The second is groupthink, because most integrity decisions are not made in a vacuum.
Yeah.
Right. It's usually not a single person that just makes a decision all on his own. Anytime there's usually some type of challenge or question about the data, it usually ends up with a few people from the operator.
You want to call. So the operations crew says, man, are you really going to make me dig this on Farmer Joe's land again? We were just there 2 weeks ago.
Right. And so I want to give you another way to think about groupthink is jumping on the bandwagon. Right. That's another way. Point is people, we all have some degree of wanting to conform and fall in line. And it's very difficult to stand out when you have 4 people staring at you and you're the only one that thinks the action that's being taken is incorrect. Very few people have the stomach, the ability, the willingness to be that uncomfortable in public.
Well, it's exhausting too.
It is. And you get that knot in your stomach. Like, am I about to be the one that's about to speak up and say that I don't actually agree with the direction that we're taking? I've had to do that before, and it is like you feel the sweat on your brow,
Rhett.
your palms get sweaty, you get that sick feeling in your stomach.
No, see, you're making it about how you feel.
But
But there's another component to this. I won't get a promotion. I will not get a promotion if I'm the difficult guy. I will not get a promotion if I'm the one that's always trying to investigate, or if I keep asking my boss questions. I will not get a promotion, Rhett. Why would I speak up? Fall in line.
You know what you're saying. You're bringing up an economic aspect to it that I didn't even intend to go into, but that is also very real. And that speaks to the culture of the organization and the culture of the managers, hopefully, that we're talking to. But I want them to appreciate, and I have to give credit to Miss Producer for bringing this up. There is a famous study that was done. It's called Solomon Ash's Conformity Study. And in this study, what they did is they brought in people. I don't know if you ever participated in psychology experiments at U of H. I did at A&M, and when I took psychology. They bring you in, and Chris, they do something like, in this particular case, they asked you to match the length of a line to several comparison lines. So like choose A, B, C, or D. Here's the length of the line. It's a very, very easy task to do. What they did is they had one person who was the subject test study, and then they had 3 other people who were paid actors. The actors all chose the wrong line, even though it was obviously wrong.
The same one or different ones?
I don't know that, but assuming they chose the same one.
So they all agreed the same one. So it's clearly a 3 against 1.
Yes. And the one guy's looking. 75% of the time, the study participant would go along with the other 3 and choose the wrong line, even though they knew it was wrong. Because it speaks to the power. So that's 75%. So I said most people don't have the stomach. This study's telling us 75% of the people don't have the stomach. And I think us as integrity managers, or ILI community out there, need to recognize that. When you have 4 people on a call discussing a bizarre ILI signal or discussing the results of a pressure test, and you're trying to figure out why is this happening, you more than likely, out of that 4 of those people, 3 of them are going to be unwilling to be the one to just stand up and say,
I think this is wrong.
That's me. Yeah, I think that's wrong. Right. Think about the control room episodes that we did.
mean,
how does that play out? Remember, because we had that one person who kind of assumed the role of expert in the Enbridge failure, right? If you have one person who assumes the role of expert, provides an explanation that everybody can get behind, the one person who's sitting there and says, this is horse crap, might not be willing to stand up and say, this is horse crap.
And to be clear, our whole little that whole little skit we just did with the type Bs was exactly what we're trying to do here, right? If you and I are viewed as experts, for a second you might have thought, yeah, I agree. And then we flipped it on you. We're like, no, that's wrong. Like, we have numerous times found blatant cracks in type B calls. And we were trying to model that there. And I also want to say this to the audience, guys. Rely on your fundamentals.
Yeah.
Right? That's why you're hired, right? If you go back to your interview, when you were interviewed, we asked you things like, why should I hire you? Right? You're like, because I'm a problem solver, right? I investigate. I'm diligent. I want to be part of a team where my voice matters. Don't forget about that stuff, right? Ask questions. If it doesn't make sense, ask more questions. If it doesn't make sense, ask more questions, right? If the math is not adding up, keep asking questions, right? And the second thing is this also kind of makes you think a little about, and not that we need to get into it, the idea of personality tests, right?
Yeah.
And formal training, right? If this study's showing that on average, 75% of people won't have the personality to ask the right questions or to create conflict, then you almost need to start looking at your team construct. And not that you want one type versus another, but maybe that's the value of having a little bit of that involved in your team making.
So you're bringing up some good lessons. I'm going to leave two others that actually were directly out of the book I read related to this. And they talk about decision makers.
Yeah.
So what you need to realize is, again, I want to go back in the BP incident, there were 5 people, but the BP company man was the decision maker, but he was not able to be effective in his decision-making process because of the peer pressure scenario created by the group. I think you can see obvious parallels to integrity engineers, maybe integrity managers. And we need to recognize that, look, we all might want to think we're that 25%, but studies show at least 3 out of 4 of us are not. So don't say, oh, I'm the 25%. I'm the person that's willing to do it.
Or walk into the office tomorrow and all of a sudden try to become the 25%.
Yeah, exactly.
You might get walked out the door.
I
So
think
just be careful.
The challenge here is it says that for the decision maker to be effective, they need some isolation from the group, right? That in some sense, before they issue their decision, they need to be able to withdraw so that they can take all the information in without somebody telling them and make a decision. I think that there's some merit to that. There's some merit to think about, hey, as a manager in integrity, if you have to make a truly impactful decision, maybe in an HCA or related to an excavation or related to taking a line down, that decision maker might need some time alone to think about all the data he's been presented with and make a decision free from influence. The second thing, and I think it's neat, and companies do implement this, I've seen it, is the role of a devil's advocate. So in a group of 4, they assign one person to be the one that always comes up with an alternative view and has to defend it, right? They're basically assigned the role of critic. Again, that's something that not everybody's going to have the stomach for. I mean,
Yeah.
I might enjoy the role of critic because then I just get to like poop on stuff and be a jerk. That's
Siegel
not how they
engineering,
should
baby.
actually be, right?
Siegel engineering.
That's not how they should actually be. But the reality is a lot of people will feel that's what they're being asked
Yeah.
to do, right? You're asking me to disagree with the team. I don't want to be the person that has to disagree. But the reality is there is merit behind stopping in a decision-making progress and saying, hey, we all seem to be in line. One person, give me the reason why we shouldn't do this and make the case, right? Like give intentional space for the other viewpoint and something that doesn't just fit within normalization. So.
And we have seen that manifest sometimes. And I'm gonna turn it on us. I mean, our role presently is consultants. And consultants play an important role here, right? You know, we have a couple of clients that reach out to us often and say, hey, I just need a third-party opinion.
Yeah.
Kudos to you guys for recognizing that. And there may be different drivers for why y'all do that. Maybe it's economic. Maybe it's because you actually have some legitimate doubts. Obviously, consultants play a good role there, but also as consultants, just be careful, right? I mean, we've talked about this before too,
We have
right?
our own biases.
We'll have our own biases and that, you know, our livelihood is founded on certain decisions that are made. Right. And so just that whole idea of it, if you are in that role of consultant and you're brought into these rooms, just appreciate your duty of care of being fair. Right. Sometimes your role isn't always to find a problem. Right. And so just be cautious there.
Sometimes not. It's always not to pass off the problem either. So, again, I'm going to wrap up this episode on Macondo, and hopefully to the audience, again, this is not a series like BP paid millions in fines. There were criminal convictions that followed. But the actions that directly led to it, of the 5 people that were there, put yourselves in their decisions, with their shoes, with the economic pressures that they faced. Those are not altogether different than what we face.
Yeah.
Those are not, when we are faced with challenging information on interpreting ILI, or maybe even the results of a hydro test, or making an integrity decision about something that we think is critical. We find ourselves in similar situations, 4 or 5 people on a phone discussing the results. Recognize the role that groupthink can play there. Recognize the strong incentive to want to find a suitable alternative explanation that isn't an anomaly or doesn't reflect that. It's not difficult to put yourselves there as an audience. Again, hopefully you reflect on that and really think about that in your roles as integrity engineers, integrity managers, maybe even, I know we have like VPs and some more senior level people. Think about that role that it plays on your team, and hopefully we can learn something from this failure.
The consequences are clear, right, Rhett? I mean, this failure parallels what we do so close. I think you said, there was a comparison. I think you said that to redo the cement, or would have been $128,000 roughly
to do the cement bond log test.
Yep, 128 grand. But I think the total cost of this failure is now north of like $60 billion roughly, and 11 people lost their lives. I mean, how many times do we see that? Right? You don't run another pig, or you don't do a couple more digs, or you used a different repair type, and to save a couple $1,000, which in the long term, again, all those things add up, and we agree it's a business.
Yep.
But if that's going to be the case, enable your team to ask questions, encourage them to investigate and not confirm.
All right. So hopefully you enjoyed this episode where we tackled something that was non-pipeline with a lot of pipeline application. When we come back next week, we're going to talk about our most recent failure, and it's a pipeline one. Thanks for joining us, and we'll be back in 2 weeks. Credits for this episode go to Sarah Etier, our executive producer. This episode was written by myself, Rhett Dotson. I'd like to give credit to the Work Lodge for the room that we use, and also our source material, Disastrous Decisions, the Human and Organizational Causes of the Gulf of Mexico Blowout by Andrew Hopkins.